In this example, we are going to show you how a durability analysis can be carried out using winLIFE Quick Check. First of all, we load a model which we have already created into FEMAP. In this case, a notched shaft subjected to 3 static load cases: tension, side load and torsion. The size of these static forces will of course be selected with thought. Take care that they show values which are of interest to the user. With winLIFE, we still have the possibility of introducing multipliers to scale these static forces. We will now create a surface group for this model and will put into it all the surface nodes. Then the stresses are exported into winLIFE. To do this, we open the dialog. We select multi-axial export and solids since we have no plate elements, and start the export. We must give the export file a name, which we can also use again in winLIFE. Then we must select the load case we wish to export. In this case, the 3 load cases. For the node selection, we take the surface group with all the surface nodes. The data is now written into a file. That is what we can see here. This file contains the stress sensor for each node, so 6 components. The number in the first column is the node number. So we have written out the data and will now go over to winLIFE. Here we want to create a project, a quick check project, and we will call this example 18. Of course, we need information on the stress capacity, namely an SN curve. We select the generator according to FKM and generate an SN curve for the load case bending, i.e. for combined loading cases. This is the matching loading case. We enter the static material properties, namely RM, RE, and the roughness of the components. Here we enter the size of the component through the effective diameter and generate the SN curve. The data of which we can see on the left-hand side of this input mask. What we can see here now is the graphic of the SN curve. Now we will open the FE data dialog and take a closer look at the first load case. We enter the constant. For this load case, we enter a multiplier of 20. The static load is therefore multiplied by 20. The calculation of the endurance limit is carried out, and here we have the results for each node, and we can see that if the load is constant, then the degree of utilization is practically naught, the amplitude is naught. Now we want to look at the second load case in a similar way, but here we will not select this second load case as a constant. Instead we select alternating R equals -1, and as the multiplier we select factor 40. The result here is interesting because we actually have the amplitude, a degree of utilization, a safety for the individual nodes. That means that for this one load case, we can look at the safety against durability and degree of utilization. The degree of utilization here is about 20%. It's 0.208. So now we come to the third load case. We select this third load case as a swelling or pulsating load. R equals 0, and here the multiplier is 30. the static load is multiplied by 30. The result follows, and for the third load case we can see here the degree of utilization, safety against durability, etc. However, we are only looking at the load cases individually to make it easier to understand. We actually need the combination of these three load cases. That is what is happening now. We select our first load case and enter it as a constant with a multiplier of 20, as we did with the single load cases. Then we select the second load case. This is selected alternating with a multiplier of 40. And the third load case is now selected swelling with a multiplier of 30. So those are the three load cases, and now winLIFE Quick Check will calculate the worst case combination of these load cases and show us the results. For all possible load case combinations, the values are shown and the critical load case is marked here with a star. The critical load case has a degree of utilization of 0.296. Now we want to import these results into FEMAP. To do this, we load the neutral file, which we called example 18. winLIFE created a results set and we want to access that in FEMAP. Here it is, and we will select it. We can see the degree of utilization and the critical point, shown by the colored scale, is 0.296. That means that the degree of utilization in the notch is 29.6% for the worst case combination as far as the durability is concerned. So I hope this example was of help and that you can now carry out your own calculations successfully.